God, you know, anyone else would have just turned into a right twat, but you were just like, this is so funny. Yeah. I'm not doing anything.
You got to run with what you got, but the fourth trip to town, that was it. It's not going to happen.
You're watching Brupeg. We're launching in 2 weeks. Okay, only half of that's true.
Here she comes like the rays of the sun, she shines.
Duncan's back. We had some cake and coffee, and we got straight to the point of it. Look, it's just there. See? Mostly on that bit there. Right, time to get into this radar and our engine control system. We've just been playing with the radar, learning some of the settings, and what we've found is these returns here, if you can see over the far distance, they're the big sugar sheds right over the back here, those big tin sheds. And then if you just sneak through there, you might be able to see there's a shed over the back there. That's the return coming off right in front of the boat. But one thing that we found was pretty cool, we've got this shape sort of showing up here as a return. If you look at this is our harbour. This is actually upside down, but this is basically in the same orientation as the radar. If we zoom right in, you can see that little estuary. You've got the far side of the river, and you can see this little estuary in here. This is the far side of the river here on the radar, and then you've got this estuary in here. So if I come out a fraction, you can see it a bit clearer. You've got that shape there. So the radar's showing us basically the features on the river, and you can see the river sort of coming up here, getting wider in this area here, and then sort of snaking off up the top, which makes correlation with the shape of the river here. You've got the river coming up, getting wider in this area here, and then snaking off up to the right hand side. Exactly what we're seeing on the radar. So.
And what were you saying, Duncan, about the sound?
I was wondering if it was more to do with the drive gears on the radar itself. So I think putting in some rubber mounts will help it a lot. But if we actually power down the radar, the sound will subside even though the head's still turning. Yeah. So I'm wondering if it's the drive gears, which may be a wearing in thing. The radar, I think, is only 10 hours old or so.
Yeah.
So one thing might be just to let it run for a while and see what happens, and see if the gears wear in a bit. Yeah. Or if it keeps on going, have a look at the drive chain. But if we power it down,
so let's just
so you could hear it was overdriving a little bit. The head was overdriving the gears, and the gears were not as noisy when that happened.
Yeah. So while the guys are doing the proper things, I've looked at this. I think we need like a skull or something on there.
Yeah.
Or like, I don't know what, something other than that. I think there's an opportunity not to be missed on that. I don't know what they're going to be, but we could make them interesting.
I think you're right. With Duncan here, we're going through all of our systems. We've got a stack of parts. So we've got multiple temperature sensors. We've got oil pressure sensors. That's the manifold air pressure sensor. These ones are other things. These are like fuel pressure, inlet, outlet fuel pressure, something else. We've got various different voltage converters, so we can convert, say, 24 to 12 or 12 down to 5 or things like that. What's that one for?
So that's the interface with the exhaust gas temperature. That's the interface between the sensor, and then that plugs straight into a computer, which will be our Raspberry Pi.
Okay, awesome. Cool. We've got a new screen, so Duncan bought us a new screen.
It's incredible, Duncan. Thank you so much. This new one doesn't have the glare problem the old one does. The other one just wasn't very bright. It's also bigger, this one, which means we can put more information on it. We can display more gauges.
Over the back, we've got a whole bunch of heat shrink. We've got some Cat6 cable to run. Nav lights that have to go in soon. We've got AIS up here that needs to be fitted, so that's our new AIS. We've got various cables so that we can connect all of the different parts. This is our VHF system that has to go in, the mount for the VHF. What's in that one?
Lots of things. So this is prototyping equipment for the engine bay, and one of the things looking at ultimately if we're controlling the fuel, so whether it's diesel or biodiesel, so these are relay outputs that we can control to switch things.
Okay, so like ball valves to control different fuel flows and stuff. Okay.
Yes.
Yep.
For anyone who's confused and wondering what's going on this episode, the guys get quite a bit done. Dame fabricates mounts and gets the new engine room sensor box in. The guys remove the old analog wiring and replace it with digital cabling. With the help of Scott, thank you Scott, they update the firmware in the new modem so that Duncan can get it to talk to Starlink and the rest of the boat. And the red arc gauges get relocated into their new position in the engine bay.
These are red arc gauge system that we had up in the wheelhouse. We're going to be changing those and putting these, we're still going to be using them, but we're going to be relocating them into the engine room. We also have the two North Star displays. They're staying. We've got our panel that we made a couple of weeks back. This is the new display. We're about to hook all of that up. Duncan's just working furiously at the moment with, this is the old display, with our traffic cameras running live. So these cameras are basically a proxy for engine room cameras and cameras in the bottom end of the boat. We've also got a bit of a setup here. So we've got a 12 volt power supply here, so we can get some clean power for all the various things that need it. We've got dual Raspberry Pi. So if I just skim in there, you can see there's 2 layers of Raspberry Pi sitting there, and that's our double redundancy. So if one fails, we just literally swap the wires over to the other ones, and we've got essentially a duplicate sitting there right ready to go. We've got a power feed here, so we're taking I think this is 24 volt from memory.
That's, yeah, anything from 12 to 24.
Okay, and what's it going down to? 5?
Knocks it down to 12.
Oh, 12, okay.
And then that takes it from 12 down to 5.
Okay, lovely. So we're getting basically clean supply, because we know we're going through these, we're getting, you know, there's not going to be any big variations in voltage and things. And then finally, we are moving all of our sensors into the engine room shortly, and we'll be bringing those up. So I'll give you a walkthrough of what we're doing in the engine room. This is going to be mounted inside Brupeg's engine room. So this is going to be sort of a control box for everything. Everything is sensors. So these sensors all go into the engine and various things. We've got fuel sensors, temperature sensors, pressure sensors, oil pressure, we've got exhaust temp, various things that we're measuring on the engine. Inside this box, these sensors all run up to either this controller here or this controller here. And this converts into NEMIA and this converts into Ethernet. So both are powered by a 24 to 5 volt converter, or 12 to 5, it doesn't really matter, it does both. But basically this gives us clean power into this box, and these give us a signal that we can transfer through either a NEMIA cable or an Ethernet cable. So these 2 cables here basically work their way up to the bridge, and that's essentially the only thing that's carrying our data up to the bridge. We don't need any other control cables. Of the 2 cables coming from the engine room, we've got NEMIA and we've got Ethernet. So the NEMIA comes through to a NEMIA bus, where we've got a Yacht Devices gateway, and this converts NEMIA into Ethernet, so we can then bring it into a switch, multi-port switch, you can see here. We've also got a power feed, so we're injecting power into the NEMIA network via this fused feed here. The Ethernet that's coming from our engine room goes straight into the same switch. This plug here is straight into the same switch, and then from there we bring it out to a Raspberry Pi. In this case we've actually got dual Raspberry Pi for redundancy, so if one breaks we've got a backup running simultaneously. And then from here it goes through a USB cable over to a custom board inside here that Duncan built, and this brings out a NEMIA feed that connects to the North Star, so that's the radar and the left-hand screen on the wheelhouse bridge. Now that we've got a basic layout figured out, we've got to figure out where we're mounting everything. A couple of things that we do need to do though, we've got our Starlink router and we've got this router here, RUT 950. So this is a 4G router, so these antennas here, this is a main antenna and this is a secondary auxiliary antenna. These are the 2 aerials that you can see here on the radar mast. These here create an indoor Wi-Fi network in the boat, and this is going to become the brains of the system in terms of internet connection. So this will talk to Starlink, and Starlink will be a primary connection to the web, and if Starlink falls over, there's no satellites, whatever it happens to be, this here will jump over to a 4G connection. So it has 2 4G SIMs in there, so we can have 2 different networks. So essentially we'll have 3 layers of redundancy when it comes to internet, which is really important for us. We're very internet dependent, being a YouTube boat, we upload everything, we're constantly moving data around, so that matters to us to have that. But this is also going to be a hub that controls a lot of things on the boat. So this from here is going across to a switch. The switch is going to be located somewhere under this area of the boat, and that switch is going to segregate the data that's coming up to the navigation and the screens here. It's going to segregate that off from the data that has to flow around the boat for the editing of our episodes. In the engine room, this box needs to be mounted somewhere where it's not going to get in the way. So I'm thinking of putting it up here, because you can't climb over this area of the boat. There's nothing that it's going to stop. We can't, it doesn't stop us getting access to the fuel filters or anything like that. And it also means all of our cables are going to come out of the top of the box and be able to run neatly either along the roof or cable glands out the bottom, and they can run almost directly onto the engine. So very short cable travel and also really easy cable management. Now to mount this, I went to the scrappy and I found a piece of folded stainless, and I was just going to mount this, cut it to the right size and mount this up on the roof here. I can just bolt it through the ribs, and then that there can bolt onto the back of that box. So Let's get this cut up and let's get the box mounted in, and then we can start running some cables.
From my winter hell, I've got candles and candy. I can be your daddy if you only let me creep into your prison cell. Hey baby, can you tell I'm not a criminal? Your choice is seminal. I want you to stay true to what's right for you.
Right, bracket cut, 8mm holes in each end, so these are going to bolt onto the rib above the box. I've offset the box so this will actually sit like that, basically off to one side so that we can get the most amount of room, and also it means that we don't have any daggy bits like that down there that are going to smack us in the head. While I've got a gentle simmer going on fitting this mount into the engine room, Duncan is squeezing ones and zeros between some modems and making sure the network talks to each other. At least that's what he told me he was doing. Before I forget, I need to epoxy some timber so that it's ready for when we need it in the morning. This is just a straight wood epoxy 5:1 ratio. I'm going to put it over some plywood so that we can have a non-conductive surface on our mounting board inside this box.
But it's up to you now to choose. I want you to stay true to what's right for you. No matter who or know what will others say, just find your way and try to stay true.
Now that we've got the non-conductive surface epoxied and screwed down to that steel plate, that plate gets bolted into that box and we need to, but that gives us the ability to start fastening all the various parts onto that board. We can start laying out our electrics run in the engine room. Up the front end of the boat, Duncan's been fossicking around with internet connection. How's it going?
Pretty well. We've had a couple of wins.
Yeah.
So what we're trying to do is make the this RUT 950 the main gateway for the boat.
Yeah.
Which then connects to the Starlink. One of the features of these is it's got multiple failback systems. So it's got 2 SIM cards which then can go to the 4G LTE network. So it can fall back to that as well. And it's also got some other options for failback. Damien and I applied a bunch of software updates to this last night.
We phoned our mate Scott as he'd just installed half a dozen of these, so it was awesome to have his support. Thanks, Scotty.
And turns out the new software update allows this to connect to Starlink via wireless as well.
Fantastic.
I'm now going wireless from there to there, and we've still got wireless broadcast out of this as an access point for the boat. What I've also discovered is the 2 SIM cards were in back to front. So the SIM card we had...
It's possible that I might have done that.
I don't think we should admit that on air.
Okay, sweet as. Cut this bit. Definitely cut this bit.
Yeah, cut this bit.
Yeah,
that's gone.
okay, good.
Yeah. So we could say there was a design change,
yeah,
and we misinterpreted.
We could say we mounted it the other way around.
We could.
And I
yeah,
did
that's
change.
right.
Yeah.
And you know, it's the southern hemisphere. I think that makes a difference too.
Yeah, true.
And when I did that, it all came to life.
Fantastic.
So it's connecting to the Telstra network, and we've got a tower, a few K that way.
Yeah, something like that.
I think, yeah. Okay, so we've got 26 millisecond ping, which is naturally a bit better than Starlink.
That's actually pretty good for 4G here.
And at the moment, what are we getting? 8 down, roughly.
Yeah.
It's interesting, the upper's higher.
Yeah. Which for us is actually a positive.
It is. So you must be the only YouTuber around here.
Yeah,
YouTube channel.
They specifically put a YouTube tower in.
Must be what it is.
Yeah.
Yeah, so that's good.
Or they put the tower in upside down because it's southern hemisphere.
There's that again.
They didn't factor it in.
So maybe their SIM was back.
Yeah. So we did a run into Bunnings, where lowest prices really are just the beginning.
Bunnings Warehouse.
Nuts and bolts collected, so that allows us to fit that box into the engine room. Now it's off to J-Car to get some electrical equipment. So we had to go and buy some new tools because we don't have a crimper that's going to do it. So this is the tool itself, and then you can buy various different crimps. So we got a smaller version of this so that we can do the coax crimping with these multi-tools. So we've got a few things. We've got some bus bars for our negatives, we've got our crimping tool, we've got some standoffs, we've got this cool looking braid stuff that we're going to use to hide the loom and tidy it up, and then we've got some SMA fittings over the back for the antenna. Time for lunch, bit of a group think, and then a layout design conversation for our engine sensor box.
The wires that come in from the engine sensors, all of them have to have a ground of some sort, 0 volts, so that could be one of these two.
Yep.
So we've got our cables coming through here, so our network cables.
So if we need 5 volt power, we're running off the bus.
So the radar gauges, yeah, we can take the fused connections to them.
Yep.
Off this way.
So we've come up with what we think is, we'll call it layout 1.0. So we're going to have our anemia down the bottom, our Ethernet up the top here, which allows us room for extra whatevers that we decide to put in later. Power supply is going to be up the top here. That's the 5 volt converter. It's not power supply, it's 5 volt converter. We're going to be doing a 12 volt fuse block up the top, and we'll leave half of it in there. And then we've got 2 of these guys here. We're going to mount those, one here and one there, and it's going to be positive and negative for the 5 volt supply. And the 12 volt fuse block is what's powering this 5 volt converter.
So we've got the network cables that generally come in this way.
Yeah, so they'll come in through the top, cable glands through the top, and then we've got Ethernet and anemia, and so they'll all run down this one side, as well as power. Power comes in that same thing and then comes over to this, the 12 volt and then through to the 5 volt. And then down the bottom, we're going to have all of our main cable runs for the engine come in this bottom plate, cable gland in the bottom here, and then they're going to go off to the various pins on these guys here. Finally, on the door, we're actually putting red arc gauges on the actual door itself. So we'll cut the door, put the gauges in, and they're going to sort of sit, down in this area here. They'll sink back down from the door a wee bit. So the underside of this board's just been sprayed with lacquer, so we'll do the top once we've got everything plugged into it and so on, but the bottom side is protected.
And we'll get some hot glue a bit later on as well, and we'll just put a little dab there just to prevent the board popping off again.
With our box mounted on the wall, we need to run the cables next. So the cables are going to be coming out the top. We don't know exactly what size hole we need yet, so we're getting a cable gland in the morning. We know roughly the size cables that we need, but we don't have the gland. So they're going to be going along the wall over the back. Got some cable tray on the very far wall there, and then all of it leads to this box here. However, this beautiful wiring that Richard did yonks ago is actually not going to be used anymore because we're changing everything about what we're doing with the red arc gauges. So we had these 2 big conductors that we sealed off for water. We did all sorts of stuff for redundancy. We've got 2 spare. Each one of these has 18 cores in it, 18 conductors. And we've got 2 spare. So these are not going to be used anymore. In fact, none of them are going to be used. All 3 are redundant now. So we're going to be pulling these out. So that's the next step, is to go in the battery box and start hauling them from the other end. Okay, 1 or 2. So we've got 3, 1 or 2. There we go.
This is like the soup can telephone.
Right. Doesn't want to move.
You had number 2 then, I think. It moved a little.
Yeah. Okay, I'll try
That's it.
No, that's stuck too. I'm going to go get some snips and just take some cut wire, zip ties off so I can get a bit more oomph.
Okay.
Okay, so it's 1 or 2 that I need, isn't it?
Correct.
Is that moving?
1 is moving a bit. Yep, go ahead. Go.
Bloody hell. Yep.
Do you want me to come and do this?
No, it's all good, it's all good.
It's getting easier as more comes out.
You're about to hit the first curve.
Yeah. There we go. Oh, there we go. It's getting easy now. Okay. 1 or 2. Here we go on 2.
How many metres do you reckon?
Let me just do a real technical measure. 1, 2, 3, 3.5.
Oh, beautiful.
Conduit length is, I really should write that down. The amount of times I've wanted to know that number. Okay, number 2.
Go ahead.
Okay, 2's out.
We'll need to put the mouse on number 3.
Righto. Now that we've got those 2 cables out of the way in this box, it's time to run this black cable, which is our Nemia cable, and then we need to run the blue coiled up cable there, that's Ethernet, so we need to run that shortly after. What we're going to do is pull this Nemia cable through, and at the same time we're going to use this rope here as our mouse line, which will then pull the blue cable through. And the cable that we're using to haul on everything is this big grey cable here, which is connected to all of these connectors beautifully. Alright, here we go.
Yep.
And we're stuck. Okay, I'm out now.
Up. Sorry?
Yeah, I'm out.
Woohoo!
Right.
Beautiful. So how many metres of Ethernet should I allow for?
How far was it through here? 3.5.
I think that's what you said.
So we got 10 if we're doing duplicates. So if it was me, I would just go to the middle.
Yeah, of the whole roll? Yep.
Yeah. Maybe that's the easiest way of doing it. Okay, I've got about a foot out.
Okay, you can pull Ethernet, but don't pull the draw. We've run out of draw.
Yeah, now that we've got the cables run up here in the wheelhouse, the Ethernet and the Nemia cable are going to be fed along these cable trays and then up the wall, this cable tray here, and then disappearing up into the hole there and going back into the various IT systems, whichever one needs whichever cable. And that morass of grey cables down there is no longer needed. That's all surplus to what we require on the boat. Common problem in Aussie, big monsters, they come into the wheelhouse. Need to get monster. Okay, monster caught. Time for like catch and release. One-handed. Actually, I'm going to go further away from the boat because I will probably end up just putting him back in the boat. There you go. Whee! Right, next job is to get this talking to the bridge. So we need to run our power cables, our Ethernet and our Nemia. We've got them run through the conduit on the other side of the, down that end of the engine room. So we've got a terminal box down there that Richard created. Beautiful analog wiring. The analog's getting replaced with digital, so unfortunately all of that gets ripped out. However, it does mean that what was 56 cables is now 3. The cabling is coming down this conduit here and into this termination box, and then from there it runs around the wall, along here, up past the batteries, up over the roof, along and then down into the box. So there's quite a lot of stuff in the way of being able to do the job easy. All of this stuff here is basically in the way. You can see the cable trays run along the back. That's what I have to zip tie to. So probably first job will be clear out some of this stuff here so that we can actually get to where we're working and then start fitting everything. I think first order of business is probably apply some boogie music. The plan is to fit everything in this split conduit. So you can see there's basically a split down there. You can see my finger inside it. It's, I think from memory, this is 19mm. But what I need to fit inside the conduit are these 2 cables. So the blue one is Ethernet and the black one is Nemia, as well as this double sheath tinned cable here. So this is going to be our power supply. This will be a DC low voltage power supply. The power supply is running in the same conduit as the 2 data cables, but we haven't, because it's DC, we haven't necessarily seen any issues with it dropping 1s and 0s and screwing up the data feed. It's pretty low voltage, very low amps. I think it's in the milliamp range, so we're talking very, very low power draw. My understanding, look, I'm probably totally wrong on this, my understanding is that it's AC that screws up the data side of things with the, the fluctuations every time it flicks from one side to the other on the hertz line. But yeah, with DC I don't think there's an issue, so we're going to be packing it all into that same conduit and then running it neatly down to that box. In the midst of all of this wiring, so we're starting to lay it out, I do have this cable sticking out, which is a anemia cable. Now, I'm going to show you on the other end of this cable. So this is one end of the same cable, two different ends, etc. But I want to show you how these things join and how we protect them in our system. This is a male and female end of anemia cable. There's a little indent in there, so they can only align the right way, so the pins will only go in one way. There we go. So it pushes in, and then you've got this free spinning part and this free spinning part. So they both need to turn. One goes clockwise, one goes anti-clockwise. It's a wee bit hard to show while I'm doing them up, but basically I'm spinning this one here clockwise and this one here anti-clockwise, and it pulls the 2 halves together. That forms a watertight seal, and if we're ever putting something inside conduit, like anemia joint inside conduit like we're about to do, we actually put heat shrink over top of the whole lot, so there's no way water can actually get into any of this.
This evening, when I heard music echo through the night, the same old songs that I heard the night before. So I started running so I wouldn't be too late. I didn't think that I would ever see your face again, but I was wrong. Yeah, I was wrong. My heart was pumping to the beat that was blasting through the night. And on the street the crowd was...
There we have it. So cables running from the junction box, they weave their way around the conduit, up over our power point, across the roof, they link across there and then down into the box. For the keen amongst you, you may notice that I've added in a little, 40 centimetre long extension, because this, once I figured out all of the bends and curves, was too short. I thought about moving this box up to the top, but we've got plastic pins mounting our board, little Arduino board that goes in there. I think it's Arduino. And we can't move that. So long story short, we put this connector in. This connector is going to be inside the box. So by the time we spit that around like that, it's still inside the box, so it's plenty sealed. This will be a completely watertight box. What I do need to do though is start fitting the terminals that go on the end of this power feed up into our fuse block. Our 12 volt feed is into the right ports on the fuse block. We've got power from the 12 volt going to our 5 volt converter, and then our 5 volt down to these 2 bus bars. So we've got a positive and negative bus bar over here. We've got our anemia connected, so this is our anemia board in here, and then up here we've got our Arduino that converts into Ethernet. So last step, terminate the Ethernet cable. That's the pin colours that we're trying to get this plug to line up with on the cable, but we're having a heck of a job with this particular plug. The anemia is plugged in and up, running up to the front. We're just stuck on the Ethernet, but we're pretty much out of time, I think.
So that might be right. We'll have to have a closer check. What we're worried about is the two, there's a green and white stripe at the end there, and they were going into the same little channel. They may have separated now, so I'm just about to put the bright light on there and check it, and if it's good we'll do the crimp.
Yeah, nice.
And then we'll do a test when we do the other end.
Alright, so where did we get to up on the top end here?
A lot of it's been setting up the AUT 950. So at the moment it's running wireless through to
Starlink.
Thank you. So wireless link there just to replace before the Ethernet cable gets here. That was just there for testing purposes, that can go.
Yep.
So this is running another wireless network, which at the moment is the gateway for this system here. So we've got the Raspberry Pi. These are all now got their own dedicated IP addresses for Brupeg.
Yep.
We've got the replacement screen yet to go in. We've got to do a little bit of a power supply change there. And part of that is we're now switching this over to be the fused 12 volt distribution for all this equipment up here.
Yeah.
And that's what Damien was wiring downstairs.
Right, this is where we got to. The box is up. The cables run through down into a gland, managed to get a new gland, and red arc gauges with our rev counter. So these are not wired up yet, but we've basically got ourselves oil pressure and oil temp, volts and amps. What's that one? That is twin water, so we can see 2 lots of water temperature sensors, and then we've got EGT and boost, so we can see pretty much everything that's going on with the engine, the general stuff that you normally look at, as well as RPM. That's fed off our new alternator, which is now a twin pole alternator. We've had that modified, so we are getting there. The box still isn't fully kitted out. We've still got our Arduino off. This here's now plugged in, ready to go. We could theoretically talk to that. We still have to do our wiring on these gauges. That's later, we'll deal with that. And then our power supplies are sorted, so next time Duncan's up, this box should be up and running and we should be talking to the bridge. I'm glad you've popped over, but I do think it's time we had a little chat, don't you?
So a momentous moment in Brupeg history right now.
We're having a morning off.
No, Damien got a haircut for the first time in like, I don't know, 10 years?
Yeah, that's true. I forgot what it's actually even like going into a hairdresser.
Because normally we use the dog clippers.
Yeah, yeah.
And you think I'm joking, but
Yeah.
I'm not.
Time for the actual talk.
So you got some news to share?
Yeah, so I left my job. It's scary as hell. We're now full-time on the boat only.
Woohoo!
Yeah. So there's a woohoo and there's a simultaneous. Schrodinger's. So what does this mean? Basically it means that I'm significantly less stressed because I was trying to jam in so much into every week and I wasn't keeping up and I was getting sick. Just like fatigue and all that sort of stuff. And I wasn't keeping up with looking after Jess either. So something had to give. And it was something that whilst I was passionate about what I was doing for my job, I'm a hell of a lot more passionate about the boat. And on a day-to-day it means that I can actually get more stuff finished. So one of the challenges that we always had was when I work on the boat, I've got 3 days to cram as much as I possibly can in, and if it doesn't get done in those 3 days, then I normally have to leave it and jump onto a new job, and it's sort of left half finished in the background. For example, the tappet covers and the turbo crossover pipe are not bolted onto the Cummins from like 2 months ago when the tune-up was done on the Cummins. And it's literally like a 5-minute job. So that sort of stuff happens all the time, and now it doesn't have to happen. Yesterday I was thinking I could just go down and bolt those on, which is unheard of because normally I'm trying to smash out like a working week in the middle of our week as well. If you have been sitting on the fence about supporting us, now is the time. We would love to have your support because it means that we can actually keep going and do this. We're able to just do it at the moment, and we'll keep going as much as we can, but any extra support, holy crap, it would be phenomenally awesome right now.
You can hear the anxiety in Dame's voice, eh?
Oh yeah, a little bit.
We'll be okay, we'll be okay. Thank you guys, we're so excited about the real possibility of getting launched and getting in the water, and Dame's feeling better every week.
I feel like we can launch like sooner now because I've got the ability to basically do double the amount of work on the boat.
Yeah, it's been so hard, and you know, you don't know what you really get when you marry someone. Like honestly, you don't. This guy has gone above and beyond in so many ways. With, you know, he ended up marrying someone who he didn't know was so unwell, and done everything genuinely possible to make this happen. And I'm so grateful, and that's what this relationship's about, really, isn't it?
Yeah.
Going above and beyond, and each giving 100% to the relationship and to what it takes to do a project like this.
Yeah.
And keeping going no matter what.
But it's not just me, like you're just as bloody amazing. Like,
Thanks, Sally.
yeah, like when I'm absolutely shattered and I'm struggling and I'm kind of going, what the hell are we doing, and all the normal stuff that
people go through when they've got a program this big that they're trying to do. Jess is like, she's like a bloody rock, you know. She's like, what's your passion? Like, come back to what your passion is, you know, come back to what makes both of us happy. Like, yeah, no, you're flipping awesome.
Thanks.
It's thanks to you guys, our viewers, that makes this possible. All the help, our Patreon supporting us to make episodes and decisions, all the amazing donations, everyone who subscribed and commented, and everyone who follows us. Thanks everyone for getting us to here.